Hi, so this is how we are going to solve problem 17 on page 115. So we figured out our two equations, change Newton's second law, specifically in the x direction, because the block is only going left and right. We don't need to worry about up and down or vectors or anything. Our second equation is going to be velocity equals initial velocity plus acceleration times time, also in the x direction. We have our two equations, but we also have two unknowns. So that means that we can solve this. We're looking for a in the x direction because part A says that it asks what's the block acceleration and velocity 1t equals 6 seconds. Part B is asking how fast is it going after 6 seconds. We are going to need to find a acceleration in the x direction in order to find velocity. As you can see, there is the acceleration in the x direction in this time-dependent kinematic equation. So let's do that. Okay, number one, we're going to isolate acceleration in the x direction in Newton's second law. Then we are going to plug in our known values to find acceleration. We know the force applied, the mass, and we also know that it's a frictionless surface. So that's going to help us. Third step, we're going to substitute that value that we found for acceleration, part A. We're going to plug that in and also plug in 6 seconds for t, because we're trying to find velocity when t equals 6 seconds. I'm going to plug that in into the time-dependent equation here. First step, we're going to isolate acceleration in the x direction. Notice that this symbol means change in. So we're going to have two forces here. We have force applied and the force that is opposing it, the kinetic friction. However, the problem notes that the surface is frictionless, so this value is going to be 0. So we just have force applied. We should get, once we isolate, acceleration in the x direction equals force applied over the mass. Okay, now we're going to plug in our known values to find acceleration in the x direction. We know that the force applied is 30 newtons and the mass is 80 kilograms. So using the rearranged equation of Newton's second law that we did in step 1, we should get that A in the x direction equals 0.375 meters per second squared. Third step, we're going to substitute the A in the x direction value that we found, the 0.375 meters per second squared. We're also going to plug in that t equals 6 seconds because we're trying to find part B, which says how fast is it going? What's the velocity after 6 seconds? We have our time-dependent equation, kinematic equation. Velocity equals initial velocity plus acceleration times time. Still in the x direction, no up or down movement. We know our initial velocity. We're going to assume that it's 0 meters per second. And we're going to plug in our acceleration and that time, 6 seconds. We should get, as our answer, velocity in the x direction equals 2.25 meters per second. So part A is 0.375 meters per second squared. That's our acceleration. And for part B, how fast is it going after 6 seconds? We should have 2.25 meters per second.